right, just a brief little lecture about vectors right here. Specifically adding them because that's the most common use of vectors in physics. To go over what a vector is, it has like magnitude and direction, which some examples in physics are velocity, acceleration, even displacement has a vector, force has a vector, momentum has a vector, energy, though, does not have a vector. Other things like okay, and vectors are expressed just as an arrow. The length of an arrow represents the magnitude, basically how much of whatever quantity there is, and then the direction, you just represent it with a theta or whatever. And then in many cases when we have like a certain object and we have multiple vectors, such as this case, the way we add vectors is just tail to head method. We start with like one vector and we put the next vector's tail on its head, so we can move this to here, and then our new vector is here. It's from there to there, but we still have to go to these two, so we go from here down to here, and now we're at here, and then back down here to here. So summing all four of those vectors would just be this little vector here, and that's pretty much it when it comes to adding vectors. These are pretty much the things we use that have vectors. There's probably a lot more, and that is pretty much all we need to know. All right, question 23 gives us a diagram of an object shaped like a box, and it has three forces acting upon it. One going up significantly, the other going down, not as much, and one going to the right. And these are three forces acting upon this one object, and it asked for us to give a vector describing the object's acceleration. So we know that these forces are all vectors, obviously in a certain direction, and that force is mass times acceleration. We know that mass is simply a scalar quantity. It's just a unit. There's no vector. It doesn't have a direction of mass. So meaning that the acceleration is in the same exact direction as the force. So all we have to do to calculate the acceleration is just to add up all these forces. And since force has the same vector as acceleration, basically, that will give us the vector for the object's acceleration. And so adding these three vectors, we can start on the head of this one, and this one goes maybe to like here, and then or maybe a little farther down to here, and then this one goes all the way to here, meaning that the total vector would be something like this, a diagonal pointing to the top right, and answer choice A is the only option to have that, so it is A.